Every agent I've tested this year has the same weak spot, and it's not reasoning and it's not coding, it's memory. You give an agent a long task, it makes good decisions early on, and then 40 steps later, it contradicts itself, or it repeats a mistake it already fixed 20 minutes ago. And the reason is pretty simple. The model does not remember anything on its own. Whatever it knew 10 tool calls back is gone, unless something in your system puts that information back in front of it. There's a real story that stuck with me while researching this. A production assistant kept referring to a client as single in an email 6 months after that client got married. The system stored a fact once, treated it like it was permanent, and nothing ever came back to correct it. That's not the model being dumb, that's a memory architecture problem. And that exact class of problem is what this whole video is about, because in 2026, memory has quietly become its own layer in the agent stack. And if you're building agents, you kind of have to understand it now. Okay, so first thing, context and memory are not the same thing, and people mix these up constantly. Context is what the model actually sees during the current request. The system prompt, recent messages, tool results, whatever got packed in there. When that request ends, it's gone. Memory is everything stored outside the model that might get loaded back in later. Different location, different lifespan, different rules. Here's how I think about it. Context is like the papers spread out on your desk right now. You can see all of them instantly, no effort. But the desk only fits so much, and it gets cleared at the end of the day. Memory is the filing cabinet next to the desk, way more capacity, nothing disappears, but you have to know which drawer to open, and someone has to actually walk over and open it. An agent needs both. And more importantly, it needs a system that decides what moves from the desk into the cabinet, and what comes back out, and when. Now the obvious pushback is, context windows keep getting bigger, so maybe this whole problem just goes away. We have models with 1 million tokens of context now. But it doesn't go away, and there are 3 reasons. First, cost. You pay for every token on every single call, so stuffing your entire history into each request gets expensive fast. Second, latency. Bigger prompts mean slower responses, and agents already make a lot of calls per task. And third, there's this effect people call context rot, where models get measurably worse at using information buried in the middle of a huge context. The stuff at the start and the end gets attention, the middle gets fuzzy. So a bigger window delays the problem. It doesn't solve it. The real issue was never storage, it's management, deciding what matters. Before dedicated memory systems existed, the field basically had 3 workarounds, and it's worth understanding why each one falls short because they're all still used today. The first one is retrieval, so RAG. Instead of putting an entire knowledge base into the prompt, you store it externally and pull in only the chunks that seem relevant to the current question. Sounds clean. In practice, it's a whole pipeline. You have to split the data into chunks, embed those chunks, index them, retrieve them, and rank them, and every one of those steps can go wrong quietly. Retrieval pulls the wrong chunk, and the agent confidently answers from bad information, and you have no idea why. The second workaround is summaries. When the conversation gets too long, you compress the older parts into a short recap and keep going. The problem is that summaries are lossy, and the language model is the one deciding what to keep. Say your agent spends an hour debugging, and the fix depended on one specific environment variable. If the summary drops that one line, and the same bug shows up 2 days later, the agent starts from 0. It technically had the answer at some point, it just threw it away. The third one is profiles, a stored table of facts about the user. Preferences, writing style, current projects, great for personalization, but profiles go stale. What was true about someone 3 months ago might be flat out wrong today, and a naive profile system keeps serving the old fact forever. That's literally the wedding email story from earlier. Nobody built a way for facts to expire, so here's the mental model that actually helped me. Memory is not a feature you bolt on. It's a loop, and the loop has 2 halves. The first half is writing. The agent observes what happened, decides which parts are worth keeping, and saves them somewhere durable. And that alone is genuinely hard because 95% of what an agent sees is noise. tool outputs, intermediate steps, failed attempts. If you save everything, retrieval drowns later. If you save too little, you lose the one detail that mattered. The second half is reading, and this is where most systems quietly fail. The agent has to pull the right memories back at the right moment, inject them into context, and, this is the key part, update them when reality changes. Updating is way harder than storing. If a new fact contradicts an old one, something has to notice, decide which one wins, and either overwrite or mark the old one as expired. Most simple setups just append new facts next to old ones, and then the retrieval step returns both, and the agent has to guess. That's how you get agents confidently citing outdated information. Alright, so what does the actual landscape look like right now? Because this space got crowded fast. The most popular open source option is Mem0, sitting at around 48,000 stars on GitHub. It's basically a drop-in memory layer. Conversations go in, an extraction step pulls out the facts worth keeping, and retrieval brings them back later. Very fast to integrate, which is why so many people start there. The catch is that conflict handling depends on the model correctly noticing contradictions when new information comes in, and there's no real version history, so asking what the user preferred last quarter isn't really answerable. Then there's Letta, which came out of the MemGPT research project, and it takes a totally different approach. It treats memory like an operating system treats memory. There's a small core memory that always sits inside the prompt, kind of like RAM, and a much bigger archival memory in a database, kind of like disk. And the interesting part is the agent manages its own memory with tools. It decides on its own when to write something down and when to go look something up. On the LangMemEval benchmark, Letta-style architectures score around 83%, which is one of the strongest results out there right now. The third approach is temporal knowledge graphs, and this is the one I find most interesting technically. Systems like Zep, built on an engine called Graphidi, don't store facts as flat text. They store them as a graph where every fact has a validity window. So the system knows the client was single from this date to that date and married after. Facts supersede each other instead of piling up. That directly solves the stale profile problem, and it's why some people are predicting graph-based memory becomes the default architecture over the next year or so. And then there's the boring option that honestly works better than people expect: plain files. Claude Code does this with markdown files that persist across sessions, and the agent just reads and edits them directly. No embeddings, no graph database, no infrastructure. You can open the file yourself and see exactly what the agent remembers, which makes debugging trivial. For a single user tool, this is genuinely hard to beat, and I think a lot of teams over-engineer past it. The differences between these approaches are not small, by the way. There are proper benchmarks now, like LoCoMo, which tests recall across multi-session conversations with about 1,500 questions, and LongMemEval, which focuses on long-range and time-based reasoning. And on temporal questions specifically, the gap between architectures can be up to 15 accuracy points. That's the difference between an agent that reliably knows what changed and when, and one that guesses. Architecture choice matters more here than it looks from the outside. One more thing that surprised me in the research. Vector-only memory tends to degrade once you get past a few hundred stored entries, specifically when facts change over time. Retrieval precision without any sense of time just breaks down because old and new versions of the same fact sit next to each other with similar embeddings, which means deleting and expiring memories is just as important as storing them. Forgetting is a feature. Human memory works the same way, and it turns out that's not a bug in us either. So if you're building something, here's how I'd actually approach it. Start with the simplest thing that works, which is usually files or a basic profile, and only move up when you hit a real limit. If your agent's world is mostly static and the job is recall, a vector layer like Mem0 is fine. If facts change and history matters, look at graph-based systems. If you want a long-running agent that manages itself over days or weeks, that's Letta territory. There's no single winner here, and anyone selling you one is selling. The bigger picture is that the benchmarks everyone watches now are long horizon ones, where an agent has to stay coherent across hundreds of steps. Reasoning is mostly there. Tool use is mostly there. Memory management is the thing still separating a demo from something you trust with a week-long task, and that gap is exactly where the next generation of agents is going to be decided.